Welcome back again to Texel Hardware. Today we're going to be reviewing one of my favorite keyboards, the IBM Model M. Now there have been a lot of IBM Model M videos that have been done out there, but one thing that we're going to fact check today in this review that nobody else has done yet, to my knowledge anyway, is test out how much voltage and power does the IBM Model M actually use, because it's very, very heavily rumored that the IBM Model M is one of the most power-hungry board designs that's ever been made. And we're gonna find out if that's true or not. And I've got a newer mechanical keyboard to kind of cross-compare between the two. So let's dive into this. So right here we have the IBM Model M right here on the floor. The reason I have it down here on the floor is because I'm using a USB hub that is on the floor at the moment, and I'm going to put my little USB voltage meter, which is right here. We'll come back to that here. So this Model M comes with a special different cord than you would find on a modern computer. This is actually an SDL to PS2 cable. It looks like an extra wide Ethernet style port. You never see these anymore on modern keyboards, of course. That plugs into this port right here, this Ethernet looking port. There's an also even older AT style port that was around one, but I don't have an example of that one. This following diagram right here denotes the different pins that are used for both ends of this cable. We have the 6-pin SDL, and we have the 6-pin mini DIN, which is for the PS2. You plug it in, make sure it latches and clicks in place. This is the other end of the cable. It is an old style PS2 port plug, and if you'll notice, it only has 4 pins on this old version, and 2 of them are for power, 2 of them are for data transfer. So it's just connected to the keyboard portion. This device is a PS2 to USB active converter. So what this does, it converts the AT signal, which is delivered over a PS2 connection, and converts it through this active converter box into USB to be able to use on modern systems as a plug-and-play device, no less. Now, I thought it was interesting to note that the socket depth was much deeper on the new one versus the old one. You can notice the socket depth is much deeper, so I think this one gets a much better connection than this one ever did. So if you're looking out for a good adapter, look for one with a deeper socket. Alright, and this is a Serago 6-port hub with 2 charging ports. It works really, really well. Although I don't really know why they keep raising the price on it. I bought mine for, I think, $38, and now they're like darn near $70. So now here is the IBM Model M plug, and it's going right through this voltage meter. Got 5.02 volts currently available from the power supply hub, and if I disconnect that, you can see that it will rise slightly here to 5.03. That's just because the keyboard itself is drawing a little bit of the power. We're drawing 0.12 amps right now from the Model M keyboard. And if I press some buttons, it doesn't seem to affect the voltage draw at all. So that's kind of interesting to learn as well. This says, reset the meter here. This is, it's drawing 0.645 watts of power. And since I reset it, we've already drawn 1 milliamp hour and 0.002 watt hours of energy from this USB port. Change the page here. We have voltage, voltage positive sine curve draw of 0.019 volts with voltage negative sine curve draw of negative 2.999 volts out of a total capacity of 5.02 volts. That's about another 2 volts that we're not using right now out of this total available voltage supply. And it's important to note here it shows the 39 ohms of resistance that it's drawing, and still drawing 0.12 amps. It's drawn so far 3 milliamp hours since we reset it. Energy capacity used since the reset was 0.014 watt hours and counting up. So let's compare these findings and these numbers to a more modern mechanical keyboard. This plug right here connects to my Razer Blackwidow Chroma keyboard. Now this Razer Chroma keyboard has the Razer green switches, which are pretty much clones of Cherry MX Blue, and I'll have to get back later to look up who actually manufactured those because I can't remember off the top of my head.
I looked it up during post-processing, and actually the Razer green switches were made by Greetech, just to set the record straight.
So what I'm going to do is I'm going to unplug. This little thing's really handy. It doesn't even have a brand name on it. There we go, focused. Yeah, it's just the product name is USB Safety Tester. Product mode. I think it's supposed to be model. China typo there. J7-T. Voltage range 3.0 volts to 30 volts with 0 to 5.1 amps. So, yeah, if you want to look that up, it's the J7-T USB Safety Tester if you want this same device. Now, I think it does have a little bit of flimsy build quality to it, and I'll probably be getting more solidly built a unit in the future here. Like I said, a little bit flimsy. Alright, now this is the Razer Chroma. Wow, so the Model M, the IBM Model M, only drew 0.12, I believe. Well, let me test that again. I almost don't believe it, because the rumors that I heard was the Model M was one of the most power-hungry keyboards out there, and it looks like that's not true. The voltage is steady on the IBM Model M at 0.12 amps. But if you plug in, if you plug in the Blackwidow Chroma, it draws anywhere from 0.11 to the 0.24 I saw was the highest so far. Wow, that is really surprising. I would not have guessed. There we go. Reset it. Wow. And that has all of the lights on right now. Okay, that's with all the lights turned off. It goes to 0.02 amps, 0.02 amp hours. And it stays right there at 0.02. So that is super low amperage draw right there compared to the Model M. So the switches themselves are only drawing 0.02 amps. So if in this case, I would have to agree that the Model M is very, very much more power hungry than the Razer Blackwidow Chroma keyboard is with the lights off. However, it appears that all those little light bulbs end up using well, almost twice as much power actually as a Model M. This has been a pretty interesting discovery, I should say. The Razer keyboard has a lot more ohms of resistance here. If you look here, 176 and tipping between that number and I think it was 300 something just a moment ago. It's quite a big difference. And it doesn't seem to be affected when I press buttons either. There's 354 and back to 176. So yeah, that's quite the big difference. Okay, so now with the lights on, the resistance is back down to a really low number. Now it's in the 30s, 40s, and 20s. I see, fluctuating. I think that's because when the lights are off, it has to block a lot more of that power because it's not being run through the light bulbs, so it has to send it through resistance capacitors. When the lights are on, it releases that energy through the lighting system, and then that creates less resistance for the power to go through the keyboard system. At least that's from my outlook on this, because that would make sense for why it's really high resistance with the lights off and really low with the lights on. Let me know in the comments if you have any other theories on that. But yeah, this is pretty interesting right here. Yeah, this is definitely pretty interesting.
Thanks for watching. I hope you enjoyed the video. Please feel free to send an email or a Steam invite. I love to play games with people.